In this video, we're going to talk about what's called local linearity and what that means for a graph. And then we're going to talk about how to do derivatives on a calculator. So first, let's talk about local linearity. If you focus on a point on a curve and you continuously zoom in on the point, eventually the graph of the curve at a point will resemble a line. What this means is if we zoom in over and over and over and over again, even a curve will start to resemble a straight line. This is why we're able to find a tangent line at a point, because if we get infinitely close, we actually see that horizontal, vertical, or slanted line that we're talking about with the derivative. So what we're going to do is we're going to graph sine of x at x equals pi over 2 on our calculators. So on our calculators, let's graph sine of x. So you push the y equals button, and then you're going to type in sine of x, and then hit graph. So let's first find out what pi over 2 is. So you go second quit, and then you push the pi button, which is second, and then this up arrow, and then we divide by 2. Then we're going to get about 1.57. So we go back to our graph, and then we're going to trace until we get to that 1.57, which is about right there. And then you're going to push the zoom button, zoom in, and enter. So you can see that this curve is starting to flatten out. So we hit trace, and then we can actually type in the value we want. So we want pi divided by 2 and hit enter. So that is the value of pi. So again, to do that, you hit trace, and then after that, you can type in any x value you want. So I go second pi divided by 2, and that gives me the 1.57. Now what I need to do is zoom in there. So I hit zoom, zoom in, and enter. And we're going to do that again. And so now you can see how this starts to become a flat straight line. So using a graphing application, I was able to actually graph this. And this is what it looks like kind of zoomed out. And then when I really zoom in a couple times, it looks like this. And then really zoomed in, looks like this. So you can see as you zoom in more, and more, we get that straight line. So again, here's sine of x over x, and here's me zooming in almost an infinite amount. And what I want you to pay attention to is the x values. The distance is about 1, 2, 3, 4, 5, 6, 7, 8 decimal places. So this is insanely close.